Alright, this is Geometry 2, Semester 2 final review. Alright, I'm going to go through this as much as I can. Hopefully I don't have to break it up into too many video parts. So, first is 1. Name the properties of the mid-segment. So, is WL, which is going to be right here, mid-segment of. So now, for it to be a mid-segment, you know it has to be 1/2 of the line. So right here, because this is actually bisecting here, because I have 8 and 8, again 6 and 6. Now the two triangles are going to be similar here anyway. So because the two triangles are going to be similar, this is similar by side, angle, side. Now the whole thing is actually going to be twice as much, so this is going to be 16 here, and same angle, and here's 12. So by the same reasoning, this is actually going to be the mid segment. So that will actually be half of my line here connecting to my half of my line here. What are the coordinates of point -3, 4 when dilated scaling factors? So what we're actually doing for each one is just multiplying by this number. So if I was going to multiply this, I'd get -6, 8 multiplied by 1/3, so that would give me -1 and a +4/3 and 2.6, and since can't remember what I'm doing right now, so let's see, 2.6 times -3, that's going to give me -7.8, and the next one's going to be 2.6 times 4, 10.4. If two polygons are similar, what happens to their angles and sides? So polygons, so it could be any multi-sided shape. So let me give a, so if they're similar, that the angles are congruent, and that their sides, they actually have, the sides have a common ratio or scale factor. So if this one's going to be 3 and this one would have to be, let's say, let's make this one 6, so it'll be twice as much. So if this one's 4, that means that one would have to be 8. This one would be 5, that means that one would have to be 10. Okay, which postulate would prove that the triangles are similar? So if I look at this, they share right here, so N is congruent to angle N, and that's going to be reflexive because it is itself. And then right here, I'm going to have this one here, congruent to this one here. Okay, and that would be angle LMP is congruent to angle OPN, and that one would be corresponding angles because they're parallel lines. And now the triangles are going to be similar by angle, angle, similarity. Now for this one here, I'm not going to be able to do the angle, angle. I'm going to have to check for sides. So this, it would be, let's see, side, angle, side, side, angle, side. It would be, but now they have to have a common ratio. So let's check that common ratio. Let's go 28 over 14, which gives me 2 over 1. Now let's check the other one. So 10 over 5, which gives me 2 over 1 also. So now since they have a common ratio, the scale factor here, so now it's going to be by side, angle, side, similarity. Using figure below, what does the concept of similarity tell us about the two figures if they are similar? So if they're similar, then all their corresponding sides should have the same scale factor. So let's see, 26 over 13 and 26 over 13, so those go together, and then 30 over 15. This gives me 2 over 1, 2 over 1, and last one is 2 over 1. So this is actually going to be similar by side, side, side similarity. Number 6, given the diagram at the right, DE is parallel, so these are parallel. What is the value of X? So I know these, so corresponding sides. So I'm going to start with 30 over 40, because those two go together, and equal to, so I'm going to do my cross products. So now 30 goes with a small triangle, so that'd be X here over the whole thing right here, which is going to be X plus 10. I have to add them since I don't know what this is, so I can't just say, hey, the whole thing is going to be a certain number. Now, cross products, 40x equals 30 times x plus 10. 40x equals 30x plus 300, because I'm distributing here. So move this over here, so I get 10x by subtracting 30 is equal to 300. So x is, divide by 10, 30. So this one's going to be 30 also. Okay, all right, let's take a look at, use the information diagram below. Similar triangles here. So I'm going to say 8 over, now what goes with that would be the whole thing, which is going to be 28, is equal to 5 over this one, which is x. So 8x equals 140, multiply that way, and divide by 8. So x is, I don't know, can't do that one in my head. So 140 divided by 8, 17.5. So x is going to be 17.5, and these are all in feet. Okay, the little one tick mark is the same as saying feet. 2 tick marks is inches, 1 tick mark is feet. 8. If we are finding point D along a directed line segment here to point here that divides segment ratio into the ratio 4 to 6, what are the coordinates of point D? So right here, direct line segment A and B. So A is -10, comma, -6. B is at 0, 4. And it says 4 to 6. So that means that together I have 10 parts to my line. So 10 parts. So the first one is going to be, so from A to B, so it would be 4 parts to here, and then 6 more parts the other direction. First thing I have to do, I have to find the distance in between here. So I'm going to use my Pythagorean theorem to find the distance. So from -10 to 0, and there's 10 apart there, and plus from -6 to 4 is also going to be 10, because we're just counting how far they're apart. So we get 100, 200, square root of 200. Kind of blurry there. There we go. And square root of 200 is 14.1. Now, this is going to be easy for this because there is 10 units in between here and here, and my ratio is broken up into 10 already. So I need to go 10 units from there to there. So for the x coordinate, I need to go 10 units, and same thing for the y coordinate, I need to go 10 units. But since they're both actually 10 units apart, that's going to make this a whole lot easier. So since I have my distance for this, it's going to be 4 to this, 4 from here to get to there. So if I go 4 this way, so let's see, 4 to this, so it's going to put me at my point D is somewhere on this line, which is going to be -6. So I get -10 plus 4 is going to give me -6. And then I do the same thing going this way. So from -6 to 4, so -6 plus 4 should give me -2. Now, this one came out to be a whole lot easier. I needed to do this formula just to find the difference in my x's and y's for this. But since I have a perfect number of 10 and 10 here, 10 to 10 there, it actually makes this a whole lot easier. So all you have to do is actually try and break it up into how many pieces you're going to have with your distance. And so for my x coordinate, there's 10 apart. For my y coordinate, it's 10 apart. And so that means that there's 6 units from here to here. So this is going to be my answer. Okay, let's take a look at this one over here. Two concentric circles, so that means a circle inside a circle, have diameters of 5 inches and 10 inches. So if the diameter is 5 inches right here, that means from here to here is going to be 2.5. And the other one's going to be 10 inches, so that means from there to there is going to be 5. So, because the big one is 10 inches all the way across. Point P lies somewhere in one circle and outside the other, so it's going to be somewhere out here. If P is equidistant from both circles, so that means actually going to be same distance. So I'm going to actually, from 5 to 2.5 right here, I'm going to take that and divide by 2. So equidistant means it's the same distance back and forth. So it's going to be 5 minus 2.5 is going to be 2.5, and I'm going to divide that by 2. So it's going to be somewhere from this circle, it's going to be 1.25 from this circle, and it is also 1.25 from the edge of this circle. So from the, and at what distance from the center of the circle, draw a picture for the scenario. So if it is 1.25 that way from this circle, but this circle is from the center, so it's actually just going to be 2.5 from here to here and 1.25 to wherever my point P is going to be. So 2.5 plus 1.25 is going to give me 3.75. Okay, construct a circle inscribed in the following triangle. Now, I have good news about this one right here for all your constructions. I know a lot of people still have nightmares about the construction units using these things. So, here's a hint. It's a multiple choice test. You're not going to do any constructions. So, go ahead and ignore this one. How does the volume of a cylinder change if the radius is tripled and the height is reduced to 1/5 of its sides? So, volume of a cylinder, pi r squared h. So now the radius is going to be tripled. So now what would I do to my radius? So I'd multiply by 3. So in the new one, it would be pi. It's going to be 3 times my radius. Right, 3 times my radius, and the height is reduced to 1/5 its side. So 3 times the radius, so that's still square, and the height is going to be, so it would be whatever the height is. So reduced to 1/5, that means I'm either going to multiply by 1/5 or just divide by 5. So I'm going to, just for the sake of this, is 1/5 times my h. So it should look like this. Write your terms of the volume, the formula of a cylinder. So if I'm going to multiply my radius by 3, I'm going to do that before I square it. And then right here, I'm going to multiply this by 1/5 to be able to get that. Alright, April needs to find a box that will hold 36 cubes. Each side length is 1 inch. Okay, now this is going to be really important because it helps me on this. The cubes must fit tightly in the box in order to avoid, so must fit tightly, damage during shipping. None of the dimensions of the box can exceed 10 inches. For example, determine if it can be used to hold cubes. Please explain your reasoning. So, this is going to be 6 inches long, 3 inches deep, 1.5 inches wide. So, my volume of this rectangular prism is going to be 6 times, oh no, you see that, there we go, a little bit better, 6 times 3 times 1.5, it's going to be 27 inches square, no, 27 inches cubed, I'm sorry. Okay, needs to hold 36 cubes. Well, this one will not hold 36 cubes, so this one's a no. Alright, so this one, 9. So it's going to be 9 times 8 times 0.5. That one's going to be exactly 36, but my issue is right here. If my cube, I can't fit a cube if it's only going to be 1/2 inch wide. So it won't hold the 1 inch cube. So I can't even fit because of this one right here. This one's 36 inches cubed, but because of this piece, this is going to be a no. Now the next one, volume is going to be 3 times 2 times 6. It's 36. So it holds my 36. This is actually 2 inches deep, 3 inches long, 6 inches wide. So this one's going to be a yes. Okay, I could stack the cubes, 2 inches deep, 6 inches wide, and 3 inches long. So having these halves would kind of mess it up big time because it wouldn't fit very snugly in there. It would shake around because I can't fit another cube on top. And next one. It's going to be 3 times 3 times 4. It's going to be 36. So, yes. So there's no issues with this one right here. Okay. So, alrighty. Let's take a look at the next side. using grid provided, what is the area of the triangle? It says 1.5. Let's see. 1.5, 1, 2, 3. 4.5, 1, 2, 3, 4.5, 1, 2, 3, 4, 5, and 6, 3. 1, 2, 3, 4, 5, 6, 1, 2, 3. Now I could find the volume of this, or the area of this, I'm sorry. These two form a straight line, so that's going to help me out. So right here, my base would be this number, and it's going to be 6. So from the 1.5 to 6, let's see, that would be 1, 2, 3, 4.5. So base times height divided by 2, 4.5 times the height, which is going to be from 1, 2, divided by 2. So my area is 4.5 units square. Number 14, what happens to the circumference of a circle when the radius is tripled? Provide an example. Circumference of a circle. So I'm going to go 1 on this one, 3. So let's take a look. Formula is going to be circumference is pi times diameter. So my diameter, this is going to be 2. Let's see. So pi times 2, which is going to be 6.28, and this one's going to be, the diameter is going to be 6, so pi times 6 is going to be 18.8, let's call it 5. Okay, so now if I were to do the comparison, so this divided by this, so in my calculator I'm just going to go this divided by this, and so I should get my, right here, my scale factor. So even though that the circumference and the area are not the same, so it goes back to going, this is 3 times as much. So when I get my scale factor, it's going to be 3, which is my original thing that I actually tripled. So times 3 on that one. Alright, so this right here, change the equation in standard form to find the center of the circle and the radius. So we didn't do this, I'm sorry, but did not have time to actually get this with the 3 weeks of AC merit testing. So I'm going to break this up. So everything, so it's got to look like this: x squared plus y squared equals r squared. So that's going to help me. And my extended form is x plus 8, or I'm sorry, x minus h squared plus y minus k squared equals r squared. So do all the math. Hold on one second. I'm going to actually do it over here because I don't have enough room to actually do this. So y squared plus 2x plus x squared equals 24y minus 120. So what I need to do here, I'm going to move this side. Move everything here. Leave this number out here. So it's going to be y squared. Move this. So it's minus 24y. And now for the next one, it's going to be plus x squared plus 2x, which is right there, and that equals negative 120. So let's break it up because we have to complete the squares for the y's and complete the squares for the x's. So now this is going to be y squared minus 24y plus something, okay, and plus, next one's going to be x squared plus 2x plus something equals negative 120. Now, so to complete the square, I have to add something to here, and whatever I add on this side, I must also add on this side. So to do this one right here, I have to take this number, divide by 2, and square it. So this is going to be negative 24. So it's actually, this number's b divided by 2 squared. So if it was a, b, c, so this would be b divided by 2 squared. So divide that by 2, it's going to be negative 12, and then square it is going to be 144. So my y squared minus 24y plus 144. Don't forget, whatever I do to this side, I must also do it the other side, so you'll see it here in a second. Plus this, same thing over here. So this divided by 2 and square it, so it just gives me 1. Okay, so it's x squared plus 2x plus 1 equals negative 120. So if I added it here, I must also add it here. So plus 144 plus 1. So I added it here and I added it here. So I do unto one side as I do unto the other. So now this will actually turn into a perfect square of, that one's going to be, take this number, divide by 2, so it's y minus 12 squared plus, this one's going to be x, this number divided by 2, so it's going to be plus 1 squared equals, now I have to put all those numbers together. So it's going to be negative 120 plus 144 plus 1. It's going to be 25. So this one right here is equal to my r squared. So the only thing I have to change is that this is going to be y minus 12 squared plus x plus 1 squared equals 5 squared. That's a perfect square here. It's the square root of 5. Square root of 25 is 5, so 5 squared just means the same thing as that. So my radius is 5, and my center of the circle, which would be right here, it's going to be 12, comma, negative 1, and my radius is 5. Alright, so now finding equation 16. Find the equation of the circle with the center here, and that passes through this one right here. Center, so the center of the circle is going to be from here, which is going to be negative 7, comma 3, and a point somewhere on the circle, which is 4, comma 1. Now, to figure out, I need to know a couple things from here to here. So that's going to be the distance, so that's going to give me my radius. I need that information. So, a couple things. I already know most of my answer right here, just by this. But I got to figure out my radius, so I need to figure out the distance in between here and here. So, let's do the distance formula. I don't have much room because I drew my circle for this. How far is it from negative 7 to 4? It's going to be 11 squared plus from 3 to 1, it's 2 squared. So distance is equal to square root .125. So distance is 125. So from there to there. So that's my radius. So I know a couple things here because of this. The center of the circle, it's going to be x. Now it's opposite of this, so it's going to be plus 7 squared plus the other one, which is going to be y. It's the opposite of this, minus 3 squared equals, now if my radius is equal to square root of 125. If the radius is square root of 125 from there to there, so in my formula, it's the radius squared. So if I square this one, it's just going to give me 125. And so like on my previous problem, I wrote it like this. So I start off with 25 was the whole thing here, but then my radius is 5. But for my equation, it's 5 squared. So 5 squared is 25. So my radius is the square root of 125. So this number out here is taking this number and squaring it, which undoes the radical. Number 16. Distance between the center of two circles A and B having a radii of 5 and 7 centimeters respectively is 6 centimeters. Based on the information, which could be following true. So now, right here, so radius of 5, radius of 7, okay, the distance between the centers of the circle is going to be from here to here. So this is not drawn to scale, so you could see this on purpose. So from there to there is going to be 6 cm. So because it's only 6 centimeters apart from here to here, so it should look something like this. So if this one is 5, this one is covering over it, this radius is 7. Okay, so it's actually going over it an inch this way. The center of circle A lies A, B. Center of circle A lies inside circle B. Circles are not in, the centers aren't inside. That's false. Right there. I'm sorry. There we go. I had the drawing, but I have to go back up to the words for this. The center of circle B lies inside circle A. False. The centers are not. The center of circle A lies on circle B. Nope. That's not going to work either. Actually, the circle B should lie on that one. So this one's false, and this one's going to be true. So if I do the math on it, so this is 7. So this one actually has to put it on there. So, okay, number 18. On the circle right here, measure QT. So QT is actually this arc right here is equal to TS. TS, so those are 120. This is 120. Find measure of angle QRS. So QRS. So since this is a central angle here, so the whole circle has to add up to 360. So I could find the arc QS because I'm going to go 360. Let's see. Minus 120 and minus 120 again for that one there. It's going to give me 120 out here. Now we know that since this is a central angle here, central angle is always equal to the arc. So that means that measure angle QRS is equal to 120 degrees.